All right, so this is the mole part 2, using molar mass, finding molar mass, all that good stuff. All right, so first we're going to find the molar mass. Now, before I do this, I probably should talk about molar mass for just a second. So let's go down here. Molar mass is defined as the mass of 1 mole of a substance. It has lots of different names, okay? And so one of the first names is molecular mass for molecules, formula mass. I've seen gram formula mass, which is the same. It's the same thing. Also atomic mass for atoms, but it's all molar mass, and so it's the bottom number or the top number, the side number, wherever it is on your periodic table. Usually it's underneath the element. And in this video I'm going to round everything to 4 digits. So that's the way I was taught to do it, and so that's the way I teach how to do it. I think it's easier to grade if everybody is using the same value instead of one person rounding to a whole number and the next person rounding to the 10th place. So we just round to 4 digits total out of the mass, and then at the very end we don't round anything. Okay, so let's come back up here. Oh my goodness. Let's come back up here and find the molar mass. And so for sodium on the periodic table, it says 22.990, I think. And so that's going to round to 22.99. And molar mass has the units of grams per mole. And so that's grams in 1 mole of sodium. So there's 22.99 grams of sodium in 1 mole of sodium. All right, so O2, oxygen gas. Oxygen by itself has a mass, it says 15.999. So we're going to round to the 4th digit. This is the 1st, 2nd, 3rd, and 4th digit. So we're rounding to that place. This 9 rounds that 9 up. Carry the 1, carry another 1. And you end up getting 16. And there's 2 of them, right? There's 2 oxygens right here. So we have to take that 16 times 2. And so the molar mass for oxygen for O2 is 32.00 grams per mole. And that's the grams of oxygen in 1 mole of oxygen. I was looking over at the sodium while I was saying that. All right. So let's move this up. Let's see if I can move this part down some so we have some more room. All right. So I've got, this is sulfuric acid here. I've got 2 H's, 1 sulfur, and 4 oxygen. And so hydrogen on the periodic table is 1.008 or 1.00794 or whatever it is. And so that's going to round to 1.008. Sulfur is 32.07. And then we just did oxygen. Oxygen is 16. And so we're going to multiply the H times 2, the sulfur times 1, and the oxygen times 4. And then we add all that together. And you get 98.086 grams per mole. And so 1 mole of sulfuric acid has a mass of 98.086 grams. All right, let's do one more. I'm going to write this one in green because it might get a little big here. So for iron is 55. Whoa. 55.85 and phosphorus is 30.97, and oxygen is 16. So this is going to be times 3, and then remember that this 2 is saying that there's 2 of all of this inside the parentheses. So it's 2 times 1 and 2 times 4. So we've got 2 phosphorus and we've got 8 oxygens. Okay, so and then 30 times 2, that is 61.94, and this one is 167.55, and so if you add all those together you get 357.49, and that's how many grams there are in 1 mole of barium, or I'm sorry, iron 2-phosphate. I can't write over there. All right. So let's look at molar mass real quick. Okay, so molar mass has the units grams per mole, so we're just going to use the molar mass for CO2. So the molar mass for CO2 is 44.01 grams per mole. So we can write it like this, or we have 44.01 grams of carbon dioxide per mole of carbon dioxide, or we can write it like this: 1 mole of carbon dioxide for every 44.01 grams of carbon dioxide. We can write it with the grams on top or with the grams on bottom, but no matter what, the molar mass has to have the units grams. And you're going to use 1 mole. I mean, you could use 2 moles, but then you'd have to write 88.02 grams are in 2 moles. So you're just doubling your work. All right? Because this right here would still simplify to that, or technically, I guess, to that one. So make sure that when you're using molar mass, you're using the mass of 1 mole, and you have 1 on the bottom or on the top with the mole, the unit mole, and you have the molar mass with the unit grams. All right, so we're going to find the moles for these. So on this first one, we have 8.03 grams of lithium, and the molar mass for lithium, which I'm going to write down here, is equal to 6.941. All right, and we have 8.03 grams of lithium. Oops, wrong color. I'm just going to use green. And so which unit has to go on the bottom? We have to put the same unit that's up here. And so I'm going to put it down here, 6.941 grams of lithium for every mole of lithium. And so grams cancels out, and I'm left with moles. So what I end up getting is 1.16 moles of lithium. All right, and that's by taking 8.03 and dividing it by 6.94. All right, and then the next one is going to be 30 grams of water, and I want to know how many moles that is of water. So water is, hydrogen is 1.008 times 2, and oxygen is 16, and so that's going to give you, if you multiply out what you need to multiply and add together, it's 18.016 grams per mole of water. So again, we're going to take 18.016 grams. The grams has to go on the bottom because we've got grams up here in the top. And that is going to be 1 mole of water. So we have what we want in the top, which means we're finished. And we're going to take 30 and divide by 18.016, and we get 1.7 moles of H2O. All right, one more. We've got 15 grams of magnesium nitrate, and I want to know how many moles of magnesium nitrate that is. So like with the other ones, I've got to calculate molar mass. So magnesium's mass is 24.31, and nitrogen's mass is 14.01, and oxygen's mass is 16. So we're going to multiply 16 by, we have 6 right here, and nitrogen by 2, and magnesium is 1. So then we're going to multiply those out and add them together, and I get 148.33. All right, so now this is 148.33 grams in every mole, but I don't have that many grams. I've got much less than that, almost 10% of it, a little more than 10%. So I'm going to put my molar mass on the bottom, 148.33 grams in 1 mole. So grams are going to cancel out, and I'm going to end up with moles. So in my calculator, I'm going to take 15 and divide by 148.33. And I end up getting 0.10 moles of magnesium nitrate. All right, let's do one more, or a couple more actually. All right, so we have 2.96 moles of aluminum, and we want to know the mass, so we want to know the grams. All right, and aluminum has the mass, the molar mass of 26.98 grams per mole of aluminum. So in 1 mole of aluminum, it's 26.98 grams. So in this one, I put moles in the bottom to cancel out moles on the top, and I ended up with grams, what I want, on the top. Moles cancels out, and I end up getting 79.9 grams of aluminum. All right, so let's do the next one. I've got 0.27 moles of SO2, and I want grams, so I want mass. Anytime you're going from moles to grams or grams to moles, you use the molar mass. So for SO2, oops, don't have room for all that. So for S, it's 32.07, and for oxygen, it's 16 times 2. And so we add all that together, and we get 64.07 grams per mole of SO2. So now, which side of this is going down here? The grams or the moles? We're going to put moles down here because we have moles up here. And so moles of SO2 cancel with moles of SO2, and we're going to take 0.27 times 64.07. And I end up with 17.3, or just 17 grams of SO2. All right, and so for this last one, we've got 4.2 moles of ammonium phosphide. So nitrogen has a mass of 14.01, and there's 3 of them because of the parentheses. Hydrogen, there's the mass is 1.008, and there's 12 of them. And then phosphorus, the mass is 30.97. So we multiply all those out and add it up. And we end up getting 85.096 grams per mole of ammonium phosphide. So I've got moles, I want grams. I know I have to use molar mass, so I'm going to put moles on the bottom to cancel out moles on the top right here. So 1 mole of NH3, or 4, 3P is equal to 85.096 grams. So mole cancels with mole, and we're going to multiply 4.2 times 85.096, and that gives me 357.4. Now, if you were writing this for sig figs, you would just say 360 grams. Okay? All right, I wanted to mention one more thing and make this very clear. If you ever have to go from grams to moles, or moles to grams, so you want mass or you have mass, at any time in the problem, you have to use molar mass. Okay, so anytime you want mass or have mass, chances are you're using molar mass to get to moles or to come from moles. So anytime you want to go from grams to moles or moles to grams, you use molar mass, because mass is grams and molar is for mole. So we go back and forth between moles and grams using molar mass.